connecting the computer.
We're waiting for Windows XP.
The question is, how many computer scientists does it take? While we're waiting, let me tell you, next week we have another alumnus, Bill Kendrick. He's going to come over from Davis. He also experienced, Peter here, the miracle of graduation. And he is coming over to tell us about his creation, which is practice painting. He developed a painting program for children. He's also a leader of the Linux group, Sacramento Davis Linux group. He's been a leader of that group for a long time.
I'm using my open office here. Everybody know about open office? It's an alternative to Microsoft Office. Okay, so here we have my presentation. And start. Okay, before I start my talk, I'll talk a little bit about myself. I actually have 2 degrees from this institution, and I'm a proud graduate from both of those programs. The first one was in environmental studies. That was back in 1980. And in those days, the next cool thing was solar energy and alternative resource development. I think I'll just tell the story that when I graduated, I had been on a work-study grant, and I worked at the Solar Energy Center. And I also, at that time, we had a class in computer programming for solar energy applications. And I just got bitten by the bug. I had to program. After that, it was all over for me. But I went to work for a company that actually the administrator of the solar energy program went to work for a large plumbing company in the area, and she actually is the one who hired me into that job directly out of school. So, and my second degree was in 1993, and that was computer science. I took a 2-unit C class from a man named Roger Meadows, who later went to work in the local telecom industry, which I knew nothing about at the time. But I was doing some cold calling. I needed a job. I was doing some cold calling one day, and I thought, oh, here's Roger's number. I called him up, and he said, Pete, you got to come and work with us. And I ended up going to work for Roger in the craft interface department at a company called DSC Communications, which was later acquired by Alcatel. So I worked there for 9 years. I left the company in, let's see, how long ago was that? Oh yeah, that was 2005. The project I was working on was canceled, so that's the reason I left. But it was part of a reduction in workforce. Since then, I've been taking some time off. I've been on a hiatus. And for about the past couple of years, I've been doing some research on what to get back into to re-enter the field, possibly not in telecom, but in computing in general. How do I re-enter that field after some time off? And I started looking on the internet, and I started studying Java. I had programmed in Java, but I wanted to update my skill set, so I started working on a certification known as the Java, the basic Java programming language certification. So that's the Java programmer certification through Sun Microsystems, and I did quite a lot of exploring to do that. Then I started working on another certification, the IBM XML certification. That's through IBM. And that also was a lot of exploring that I did to pull together all the information I needed to pass that certification. And both of those are 2 very different curricula. One is very much about the the computer language itself. And what I want to say about that is that for me, it was like Computer Science 101, again, which was a really good thing in mid-career. And one bit of research that I would recommend to anyone, not only from the professional point of view, but from the theoretical computer science point of view, is the Java language specification. If you read through that, you're going to see a lot of theory. You're going to see a lot of discrete mathematics. You're going to see a lot of computer programming language theory. And you're going to see how it's applied to an actual situation, a real programming language that's out there just about everywhere. So if you want to see how your academic work connects with the real world, that's a good bridge, especially if you're really deep into theory now. You're going to see, you know, how the Java programming language has really become like a whole community of industry, academia, practitioners, and it's almost turned into a Swiss Army knife of programming languages. It has everything in it, where when I started working with it in 1998, it was just the core language and a few foundation classes, and that was it. But their vision has really been realized in terms of, you know, I'm sorry, I need to plug my machine in, or it's going to keep doing that. And the question is, where is my... Oh, well, that's being prepared. I don't have my plug-in thing. Well, we're back. Okay, so anyway, so most recently what I've been working on is, as I was doing my research for those other things, the XML, for example, I saw something on the internet, web services and service-oriented architecture. And in fact, about a year ago, there was a professional development seminar through the Association for Computing Machinery, the SFA ACM local group here, and it was all about service-oriented architecture. And it was an all-day seminar taught by somebody who's actually been going around North America trying to help large organizations consolidate their software into services. So what I'm going to be talking about is service-oriented architecture, web services and service-oriented architecture, and how those two things are distinct. You know, when you see all these acronyms and so on the internet or in job descriptions for you know, jobs out there, if you're ever going to one of those places, you see all these job descriptions. You know, must have, you know, JAX RPC, SAX DOM, you know, Java, Python. I mean, it goes on and on. So at one point, I was just looking at all this stuff, and I went, "What is all that? What is all that?" You know, it's all these acronyms, acronym-oriented programming. But the important thing about that is that this is a way to, there's an important point to make about web services and service-oriented architecture in that they have an engineering aspect, but they also have a really heavy marketing aspect. And the line between marketing and engineering is increasingly fuzzy. I mean, commercialism is a reality in our world, and it is definitely a lot of what drives these, the need to have these acronyms. You know, it's like the shorthand for the industry. So, SOA, service-oriented architecture, what is that? Web services, you know, it's the cool new thing. Or is it? Maybe what it is, and what I've seen argued is that really it's just the next logical step in the whole history of, you know, system development, especially from the software architecture point of view. So, how do these things work? I thought I'd walk through, or at least mention a couple of scenarios, and then show you some resources. Now, I said in here that I would dig into some of the code, and my original goal was to be able to get some open source web services code, download it to my integrated development environment, build it, deploy it to a server, and then have a client piece that was running outside just on the machine, and then try to actually put some breakpoints in and say, okay, here's where the messages actually get passed and so on. Well, I have not finished that project yet. I'm still working on that. So what I will do is just try to show you some of the things to look for, some of the avenues of investigation that I've been pursuing that you might be interested in also. So this talk is really not so much me being an authority on this. I'm really just learning about it myself. What I am trying to do is trying to map some of what I knew from before, from my previous experience in education and so on, to some of these new things. And the reason being that I'm very interested in the infrastructure, I'm interested in how things work, and as I pursue my next career move, I'm sort of looking at trying to combine that interdisciplinary environmental studies point of view with the emerging interdisciplinary point of view that's necessary to really have a handle on the world of distributed computing. So, let's see, the next slide is, so, okay, what are web services? Web services are it's a way of implementing distributed computing on over HTTP. So HTTP is Hypertext Transfer Protocol. That used to be just considered, HTML, but with the advent of XML, it's now really used as a general transport protocol for not just pictures and text, but meaningful, semantically meaningful data. And the reason that's true is that XML introduces semantics into a document. So it's basically, this is a document-oriented idea. And so, having said that, it's also the case that the fundamental way that distributed computing has been accomplished up until now is through a mechanism known as remote procedure call. Now, another thing I mentioned in my little blurb was that there's a way that programming paradigms such as declarative, object-oriented, functional, imperative, or what you might want to call procedural programming, all combine in this field. So it's not strictly object-oriented, it's not strictly procedural, it's not strictly declarative, but if you have an understanding of all of those types of programming approaches, you're going to see how those are used in this. And web services have developed two flavors, actually. There's the remote procedure call, or the SOAP, which is SOAP is it's a standard object. Okay, so I don't know that one particularly well. SOAP is basically an XML-based way of packetizing procedure calls. It also can be used to just send documents or even attachments. So, although I said it was mostly procedure-oriented, it actually can be used to send documents as well. So, the thing about SOAP is that it has certain extensions that allow more control and more security and other types of standards to be applied to those messages. So I'll talk a little bit about that in a minute. So the most important thing about this is that it's all based on open standards, open source. Do we have any open source contributors in the room here today? Do we have any web services or other practitioners who are actually doing this before I make too much of a baby out of myself? Good. One thing is that I really want to say that when I am unsure about something or if I'm going to say something speculative, I'll let you know. In fact, what this is really about for me is more exploration than necessarily even technology. And I usually, when I explore, that's sort of my fundamental way of being is exploration. So I have this thing where I'll read about something, I will speculate about it, I'll test out my speculations, I'll invent some way of trying to make this speculation a little better, and then I'll try to build something. So I'm constantly switching back and forth between these various points of view. When I'm over here and I'm reading and I get a little bored because I'm sick of theory, I might start speculating on that and try to build something and test it. And so, I'm often bouncing back and forth between these things. Another thing to look at is that because this is there's such a fuzzy area between, the technical aspect and actually getting things done versus the social or the business aspect. I'm always trying to look at this thing from a couple of different axes. So you might have the social and business, organizational, strategic, and then you might have the technical here. So sometimes I'm working in this area and I notice something. For example, why did they choose that name? Often comes up. I'll show you a slide when I So this is the process that I'm going through. I'm looking at this from a variety of points of view, trying to apply what I know to the new stuff, and my main mode of operation is the internet. I'm going online. I'm looking up, I literally will stick an acronym into Google, see what comes up, and then see if I think it's a good way of pursuing it. So that's, see if I think it's relevant to what I'm looking for. So that's another way of looking at it. So what's service-oriented architecture? One of the main distinctions between service-oriented architecture and web services is that web services is really just an implementation standard, or it's a set of standards that allow you to implement something in a service-oriented way. But service orientation is really more about trying to create pieces of functionality that are cohesive enough and are loosely coupled from one another, that are reusable enough, and can go over a number of protocols. So not just HTTP, but FTP, SMTP, RS-232 with nothing on it. I mean, any protocol where you need to be able to offer something that is cohesive, meaning that it just does one thing. So if it has a name that says what it does, you can be sure that that's what it does and it only does that. Okay? Loosely coupled, meaning that it doesn't need to use other services that are at its same layer. So one of the things about service-oriented architecture is that it's a way of organizing software components or components of functionality. It doesn't even have to be software. You could think of the telephone lines, just a standard plain old telephone service, as service-oriented architecture. There are two endpoints, there's a switch, there are various other types of boxes that intervene. There's software, or in the old days it was just relays that make a connection between two parties, and then that's it. So they're loosely coupled because they don't need any other two-party connections to operate. They are cohesive because they're doing just one thing and only that. And as we know, they've become composable, haven't they? Because we can have many-party calling. Right? We can what do you call it? You can conference somebody in. So conference calls, that gives you a composable service. So that's sort of like, so if you're familiar with the telecommunications industry, if you're familiar with standard sort of telecom operating environment, that's basically service oriented. So the goal of service orientation in software is to make it that simple for businesses, business partners, customers, users of other types of things like information services, the weather service. A good example of a web service that you could see as being service-oriented is if you ever go to any newspaper website, there's always a little weather thing there, and it's changing at a certain interval. It'll be changing. It's constantly being queried for the next, when the weather changes. So that's the idea, is that it's one thing, it does it, and it can be put anywhere. You could put a weather badge on your own personal website, you could put it on a newspaper website or another website that might be, let's say, a travel thing. So I'm sure you've all cruised the internet enough to know what I'm talking about. But that's basically the idea of service orientation. Now, one of the things in software, I guess I can tell you a story from my past. A while ago, almost 20 years ago now, I was working as a software developer. I was working in a mid-sized business as a contractor with another group. And the accountant at this company was constantly needing to make new reports based on various data that he wanted to be able to pull together and display on a particular report. So he would come to us every day or every week or so and say, here are the reports I want. I want to juxtapose these quantities, and then I want a summary down here, and so I want that to come out every week, or I want it to come out every day. So one day he came to us and he said, now Peter, I want this report. I need this in a week. And so you need to put this piece and this piece and this piece together, and then I want this summary here. So you're going to have to pull from this database and pull it all together. And I said, okay, very good. And I went back and I was thinking, wait a minute. He's got a stack of reports. This was back in the days when they had, those great big printers that made a lot of noise, and they came out with this paper that was, this line printer paper with the green, and I don't know if you're probably familiar with that maybe from old movies or something, but anyway, he had a stack of reports, I kid you not, this high. Every week he had a stack of reports this high, and I was thinking, I don't know. I just started thumbing through the reports, and let's see, what's he got here? And I looked up, and I got about 2/3 of the way down, and I found the very report he wanted. Okay, so the important thing is that service-oriented architecture it has a philosophy behind it, and the philosophy behind it is eliminate duplication. So in big organizations especially, and it was, Sonoma was brought about by, the who's who of great big organizations. They're so vast, they're so complex, they're so sophisticated. It's almost guaranteed that there's going to be duplication. They'll have, when they implement, you know, it's not like they've always been implementing things organization-wide. Each department would have its own computer, and they would build their own website, and they'd have their own database for their own purposes. And I speculate that given the need for greater accountability that's been brought about by scandals over the years, and the need for greater efficiency in all of our data processing, the incredible proliferation of stuff, and think about it, how much is your business worth? If you had to sell your business tomorrow, or a piece of it, what would it be worth? What are you going to tell your accountant that it's worth? Okay, so there's accountability about, and now this is a speculation. I invite you to study this social area for yourself. But I think that from what I've seen, that a lot of the impetus behind service-oriented architecture is to make sure that you know what you've got, so you can sell off a piece of it, so you can account for it and show where your money's going, so you can see, oh, I have one department over here and another one over here, they both created the same thing, or I want to sell off this piece and I want to acquire this piece from some other company. You know, this allows this service orientation plus web services, which go over a well-known open standard protocol and set of security security standards and so on, reliability standards. All of these things are being created by standards organizations that have been really put together by these large organizations and the open source community, which is well funded by those organizations. It's really a way of becoming more agile. You hear the word agile a lot out there. It's really being able to size your organization to the right size, bigger, smaller, you know. And also to try to actually get rid of some duplication. So there's a lot of interest in this, and there's a lot going on. So again, I've already said this. So web services is not necessarily equal to service-oriented architecture. It's just a way, and probably the most predominant way, of implementing service-oriented architecture. So, yeah. Now, yeah, I wanted to contrast just momentarily. I'm not going to talk too much about REST, which is representational state transfer. This is where you're sending, basically it's mostly for interactive web pages and so on. It can be used for other things, but that's how it's mostly being used right now. And the server gets a certain packet of data from the web page user, decides which page to display next, and sends it back. So that's a really fertile area, though. That's something I intend to look into more, but I didn't have time to really go into that. Because what I'm really more interested in actually is the infrastructure. The RESTful web services has sort of been built on top of the internet, and it's evolved, it's co-evolved, it's evolved on its own, just with what you can do with HTTP and the transport layer security that you have. SOA uses the messaging, the SOAP messages, which have headers and attachments that allow the WS star standards that I'll talk about in a minute. So how does this all work? So what are they good for? I've already talked about this as well, but I'll just extend it a little bit. One of the most interesting areas to me is the electronic data interchange. Now, electronic data interchange has been around for a long time, and it's been traditionally over private networks. And they're standards. There's a standards body that has come up with packets and security protocols and so on that are not HTTP. It is an industry standard, but it's not what you call an open standard in the sense that it's used all throughout the internet. But this is something where, like when you slide your card at the supermarket, there are messages that go off to the warehouse and go off to the accounting place, and there's one that goes to inventory control and so on. And so all of these, and sometimes they'll go outside the organization, and so organizations have banded together so that there can be this automatic data interchange without somebody having to take a piece of paper from one computer and going over to another one and enter it in. So this is so now doing this over the internet and doing it with open standards is something that makes it more available. It makes it less expensive because it's based on open source, and it also broadens the number of applications that it can be used for. So publishing your functionality to the web, this is another thing. Let's say you have a distributed computing system where you work. You have an inventory control system, let's say, and that inventory control system has certain data that allow you to have, let's say, business partners or internal partners do some ordering. Now you want to offer your products not just through third-party suppliers, but you want to offer them on, you want to offer them, for example, as a direct sale to other people. For example, the wine industry, right? The wine industry in recent years was started to allow to be, the law changed so that the wine industry could ship direct to customers rather than having to go through another part. So, so they might, again, that's speculative, but I think, anybody who wants to go from just offering their goods through suppliers now to be able to offer them direct to the consumer, the functionality that allows them to do that can be taken from an internal implementation and with certain software changes can be published on the web. And there's a lot of, you can do any number of tutorials on how to do that. So that's an area that there's interest in. Internal decoupling, I've already talked about that. If you have modules that are somehow interdependent and maybe they shouldn't be, going through your whole organization and deciding what can be a service is an exercise that you can go through. You can turn everything, you can go to this second bullet, you can turn everything in your organization into a web service, but that doesn't really make it service-oriented, and it might not be, it might be a good first step, but you should think about going back and saying, okay, are these pieces of functionality that I'm exposing over HTTP, are those cohesive? Are they interconnected with each other in too convoluted a way? And so on. So, with great, there's a great power in web services, but with great power comes great responsibility, and you have to probably be careful with that. Internal decoupling, integration. So this is another thing where you might want to integrate the data from various organizations. Mashups, you've heard of mashups, right? Where people will take several web services and subscribe to them and then put them up on another website. So that might be the weather service and the time service and maybe a service that tells you when ticket reservations are available at the parking lot at SFO. Oh, very high. There we go. Another couple of things I've seen, again, web services are good for implementing. So autonomic computing, this again is something like, imagine that I have a new, imagine that I have this computer and I just come in here and stick it down every other device in here automatically knows who it is, what it's for, and you know, automatically just sends you this. So this autonomic computing then is, you know, at its simplest level, it's without human intervention. It just knows about the other devices and is able to talk to them with certain protocols. So web services are, and service-oriented architecture especially, are a way of organizing that problem and trying to figure out how to get it to work. So it gives you a starting point. Grid computing, I just saw this, I was on the JPL website, and I happened to see that there's an effort underway to try to apply the theories behind web services to actually being able to do parallel computing using, you know, many different computers all working in concert with each other to solve a problem. So this is a very interesting one, although I know nothing about it, so I won't say anything more. How do they work? Well, and thank you, that will be my presentation. My job is done. So anyway, these are the various acronyms that relate to this in some way. I have JAX RPC first. JAX means the Java API for XML, and there are many JAXs. There's JAX RPC and JAX B and JAX P and JAX R. That's all the way Sun decided to create, design the APIs for application developers to use to process XML. The reason that's important for web services is that, again, the SOAP messages are XML. Now there was something previous to that, which was RPC, which is just HTTP RPC, and that. And by the way, this is Java centric here because there's a lot of Java oriented stuff that's easy to access about this, but it doesn't have to be Java. There's a, I have up here somewhere .NET there and WCF, the Windows Communication Foundation. These are also, .NET is a completely web services oriented framework. And so, Microsoft and Sun and IBM and all these different organizations, they're all together on this, and they're doing what they can to try to make it all interoperable. So obviously I don't have time to cover all these today. I think what I did mention though is what I'll talk about a little bit to try to maybe demystify some of the process here is the RPC, and then I'll say something about WS star. But so this is one of the things I've been exploring. One of the I jumbled all these up on purpose, because just to get a little bit of a joke. But this one down on line 4 here, all the way at the end, SLA, that's a big topic. That's service level agreements. And service-oriented architecture, electronic data interchange, those things really depend on service level agreements. And there's a whole, do we have anybody here who's primarily interested in the business aspect of all this? Can I just see a show of hands how many pure technology folks have we got in here? You're into the technology and that's it. And you're, okay, very good. And how about people who are more into applications? Applications, so business applications mostly, would you say? Yeah. How many people don't know? Yeah, good. Me too. Sometimes it's okay not to know. I've done pretty well with not knowing, actually. And that's, as I look at this sea of unbelievable alphabet soup just over the top, I go, to me this is like a walk through the forest. You just start somewhere But there is a way to use your brain to understand this stuff. One of the things we could do, one first approach to this is to try to figure out just in general what they all are and put them in their layers. SLA, that's the top layer of abstraction. That's the business layer. And you can contrast that with the HTTP, which it might be at the bottom layer. One of the things that really makes all this work is OSI, the Open Systems Interconnect Software Reference Model. That's a standard. OSI is the OSI. Anybody remember?
7-layer model.
Yeah, the OSI stands for Open Systems Interconnect, but it's the International Standards Organization. So, some of these don't necessarily belong in with SOA, but they belong with web services. This one. Now, the main ones really, see, I do have some standards organizations in here as well. This is important because they wouldn't, how do they work? Well, they wouldn't work without the standards organizations. They are the ones that come up with, and that's really the whole purpose of it, is to have a standard. So WS star means anything. There are a whole set of standards that extend the basic RPC model to put security, reliability, and other types of standards on there. And again, there's a standards organization, or there's a working group for each one of those standards, and they come up with how that is going to be represented in the message stream. So this again doesn't. So I'm going to talk about RPC for a minute because that's really what this all gets down to. Now, where I worked before, I actually had to do this by hand. We had an embedded system, and there was a card over here, a control single board computer in one machine and another one in another machine, and we had our own internal protocol. And in the C programming language, we just had to, we would have a procedure call, but we would have to marshal that down. In other words, we would have to take the name of the message, which was represented somewhere, and we would have to take the parameter list, and that was in a data structure. We would have to just put that into bytes, or bits, and put it on the wire, and then unpack it at the other end. So the point here being that each end had to know exactly about that protocol. It had to have absolute knowledge, and it had to be connected in terms of the development system. It had to be connected software-wise to the same header file and so on. So somewhere in the web services world, it gets down to this: bits on the wire. Now, there are automated ways that have developed of taking more and more complicated things other than procedure calls, turning them into messages, and unpacking them at the other end. And that's what this really is. And so the fundamentals of it is really remote procedure calls. So this is procedural-oriented programming. Even though you can have, for example, you have the common object request broker architecture, which was supposed to be object-oriented, and you would have objects on either end. But at the end of the day, there was a piece of software on either end that would know about those protocols, that would know how to take the data from the client. See, when you do this kind of programming, you have a description language, an interface description language, which is not C or Java or anything like that. It's just a way of specifying the name of your procedure, the parameter list, what the data types are, and so on. And this little diagram is just basically it doesn't really correspond to anything other than just a theoretical, sort of a high-level idea of how this works. But this RPC runtime, this comes from, you have to have two little pieces on either end that have a protocol that's run between them. And in this case, this would be something that would be proprietary to a specific type of remote procedure called system. So I got this, for example, from the Microsoft remote procedure call. Look, it was in a different form that I just made. Are we almost done? We are. 5 minutes. Okay. Let me skip over. I've said most of this. What I want to say, mostly, I want to show you my resources and talk a little bit about them. So, one of the things that I find exciting is the professional organizations that I belong to, the IEEE and the Communications Society. Within that, they have an excellent magazine called Communications. In there, you'll find articles. The last year, they published some articles on the use of web services in the telecommunications network. So the point I'm trying to make here about that is that we think of web services and service-oriented architecture as being something that's for business-oriented programming, accounting, this kind of thing. It goes over the web. It might be for online shopping or something like that. It's actually getting miniaturized, and it's going all through, even to devices. So you're going to see this concept of service-oriented architecture really even to handheld devices or even smaller. The SFBA ACM, I've already talked about them. I go to all their professional development seminars. I've been a member of that group since 1988 when Professor Levine suggested that I join, and that was a very good suggestion. IBM Developer Works website, great website. A lot of good articles on there. The Java.net community, is anybody a member of that here? If you're interested in this area, I suggest you take a look at that. NetBeans IDE, I've been using that. It's a pretty good learning environment. They have the Metro project, which is their web services stack. Again, I don't work for Sun. I have a Sun certification, but basically, I've been sort of using that as a way to explore this. It's got a lot of interesting stuff, tutorials and so on. W3 Schools. This is a good thing if you want to know what some of those acronyms mean. You can go to W3 Schools, and they have a lot of the internet acronyms and little tutorials. They're not deeply technical. I mean, you won't be a practitioner by the time you finish these necessarily, but they do get deep enough into it so that you can understand where it fits in and what some of the terminology is. And that's the first step. The Apache Software Foundation, they have many different projects that impact on this. Most importantly, Axis, which is their web services implementation. But they do all. Nice thing about open source is that you can look at the code. I haven't figured out how to do that yet, but I know you can do it. Another resource, the Java Blueprints. This gives you design patterns that are used in a lot of the Java stuff, which there's a lot of Java out there, so it's good to see. And I think it's also very interesting because, long ago I was in the heating, ventilating, and air conditioning industry, solar industry, and so on. And all the big companies in that industry have their trainings that you do and their certifications that you get, and because they want the engineers that apply their systems to do it properly. they don't want somebody misapplying what they're putting out there, because that is no good for them at all. So, they want people to learn Java, they want you to learn to do it correctly, and they want you to see how it's been applied. O'Reilly and Associates, a couple of, the Microsoft RPC book is good for historical reference. XML in a nutshell, XSLT cooking. For me, those are my two most dog-eared books right now. They're pretty good if you want to learn the details. The Web Services Interoperability Organization website is a very important one to go to because it really shows how it's evolving now into a very open standard where you can really decide what it means to be reliable, what it means to be secure, what it means to be, a web service. UDDI, this is the Universal Data Discovery and Description. This is how you find out about web services. There's a registry, and it's not the only one, but it's the main one. Okay, Department of Homeland Security has a great security website. This second reference here, this is it's a highly theoretical book, but I think it's, I'm only about a third of the way through it. But this is what that seminar I went to was based on. And there's a whole series of these books about service-oriented architecture. Anti-patterns, this is just my little, I don't know how many have heard of the anti-patterns book. I like this as a historical reference and also the pragmatic program. A lot of what I was talking about with cohesion, encapsulation, layering, all the structuring and the emphasis on architecture has been brought about because of what these people learned as they were trying to do software, especially software that was bigger than just, a small department, but, mega software that runs everything. So, there's some certifications, IBM Certified Solution Developer for XML and related technologies. Good curriculum. Sun Certified Developer for Java Web Services. That's another one you can do that's Java-centric. XML Master, that's an interesting one. If you want to test your proficiency with XML and XML schema. It was designed as a human-readable language, but anyway. Java Black Belt, that has some interesting quizzes on it to keep your knowledge of programming languages and so on up. Trade shows I attend every year. Embedded Systems Conference, Java 1, and Community 1, which is also part of Java 1 that just started. And so yeah. I'm grateful for this opportunity and grateful for this institution and whatever I can do.